Okay, Assalamualaikum and hi to our beloved lecturers. So today we are from Group 3. We present about air and noise pollution project. Okay, this is our team presentation which is me Ahmad Syazan Azrai bin Mak Nafis, Muhammad Hamizan bin Zabidi, Muhammad Amir Rizwan bin Muhammad Shukri, Muhammad Arif bin Muhammad Amran and Muhammad Aiman bin Mat Shukri. I and Muhammad Hamizan will present project 1 which is air pollution index. Alright, for introduction, Malaysia will have advanced toward industrialization by the year 2020. That conclusion means that Malaysia air quality is a major concern. Vehicle dry cleaners, factories, power plants, windblown dust, and wildfires are a few examples of the various sources that cause air pollution. The responsibility for air quality monitoring is distributed at different levels consisting of protocol, international agreement, and community legislation at the national and regional levels. The Malaysian Department of the Environment (DOE) developed air quality standard for air pollution in 1989. The recommendation Malaysian Air Quality Guideline (RMG) established concentration limits for a few air pollutants that could have a negative impact on the health and welfare of the public. Alright, so what is API, which is Air Pollution Index? The first one is to indicator of air quality. Second, to develop it based on scientific assessment. And the last, to indicate in an easily understood manner the presence of pollutants and its impact on health. Pollutants have two, which is primary and secondary. Primary, this criteria, air pollutants are a group of six common pollutants, which is particulate matter, PM, photochemical accidents, ozone, which is ozone, carbon monoxide, sulfur oxide, nitrogen oxide, and lead, which can negatively affect public health and welfare, the atmosphere and environment, and surrounding structures. And for the secondary pollutants is formed when primary pollutants react with the other gases or particles, such as transformation always occur in an open atmosphere. They can be just as harmful to people and the environment as primary pollutants. As you can see, there are API for descriptor, which is good, moderate, unhealthy, very unhealthy, hazardous, and emergency.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hamizan bin Zabidi and I will continue my group presentation for the project 1. Okay, in the project 1, we choose to select the API rating data at Terengganu. That was the latest updated by 2021. So under Terengganu, there are 4 districts that was monitored the API rating, which are Pakar, Kemaman, Kuala Terengganu, and Besut. So the time that was the API rating monitored is from January until July. Okay, from the data that we see before, we produce a graph to see how much the API rating from pattern at Terengganu for the 2021. Okay, for the first district, Pakar, we can see that the highest API rating recorded was at July with 51.996. It is considered as a moderate air quality. Okay, then we go to the Kemaman district. At Kemaman, the highest API rating recorded was at April with 57.914, also considered as a moderate air quality. And for the third district, which is Kuala Terengganu, it was a bit higher than Kemaman at March with 60.13, but also considered as a moderate air quality. And for the last Besut, the highest API rating recorded at February with 58.804, but also considered as a moderate air quality. Okay, when we see the graph pattern for the API rating at Terengganu, so firstly we must know the API rating index. So the index runs from 0 to 500. The index below 100 considered as the air pollution below the level known to cause adverse health effects. So basically it means that when the index below 100, it was safe for everyone to go out. When the index hits 101 or above, the outdoor air remains safe for others, but it was a bit high risk for the older adults and children. And when above 200, it's considered very unhealthy to everyone, and above 300 considered very hazardous for everyone to go out. So basically we can see that the API reading at Terengganu was average uh, at a moderate air quality. So it was safe for everyone to go out. For the last one, for the precaution, when the index hit 200 or above, the first step we can do is stay indoors with the windows and doors closed. Second, if there is air conditioning in our house, run it continuously because the windows and doors are closed, but not on the auto cycle. The third one is close the fresh air intake to keep the smoke from going into the house. And the fourth one is avoid frying food, which can accumulate a lot of indoor smoke. And lastly is don't smoke cigarettes. Okay, that's all from me. Thank you.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmed Izwan bin Muhammad Shukri. Today I'm going to explaining about Project 2 Wine Roast. The picture here shows study data is recorded on the meteor trend at Pakar Terengganu on the online website daily basis from the first day until the 15th day. This data is taken from 1 January 2023 until 50 January 2023. Then we divide into tables according to wine direction and wine speed separation from 50 days. The result of the total amount by day is taken as an average only. With this table, we will make our work easier to record in Excel. Therefore, this is the result of the daily average taken and recorded into Excel. Through this table, we can see the daily average from direction and speed more easily. After the data is collected into Excel, this data will be imported into the WR Plot View software to be analyzed and formed into a wine roast image to read the direction and the speed of the wine at that location. Therefore, this is the image of the wine roast that has been analyzed. Then the result of this image of the wine roast will be combined with Google Earth so that we can see the wine roast more clearly. From this wine roast, we know that the wine roast is the wine speed direction blowing from. The wine roast in the bottom right corner of each data map depicts the general direction and speed of the wine throughout each sample period. The circular shape of the wine roast indicates the direction from the wine blue, and the length of each spoke around the circle indicates how frequently the wine blew from that direction. The wine roast above show that the wine blew from the northwest 64% and the time during this sampling period, and from the west and southwest 13.6% of the time. Finally, this is the result after wine roast is combined with Google Earth. Then we will be able to see the movement of the wine roast more clearly and easily to understand from this view.
Okay, I will continue project 3. Project 3 is air quality modeling. Myself, Muhammad Arif bin Muhammad Amran, and with another member, Muhammad Aiman bin Muhammad Shukri, will present the project 3. Okay, next, what is the TOFLEX online? TOFLEX is a software program called the TOFLEX based on the analytical solution to the atmospheric dispersion equation for the inert compound which is density close to the air and the potential to the experience first order chemical or the physical assay. Okay, I will continue to how to use the TOFLEX tool online. We have to first one we have to click the website online that have given by the instruction file, and then we have to click the button in example 2, which is we have to take one of the three available example, and then from the website, and then we the table uh, will show where all the data have been given, and then we have to use have to need to press the run button to get the KML maps has been set by the TOM Flex online, and then the file we have to upload in the Google Earth website. Okay, this is the example that example 2 which is our group chooses. Example 2 is winter situation class E wind speed 1.0, 1.0 meter per second, mid-stream height 200 meter. This is all the some of the table that include the parameter and the units, and this is the location on the Google Earth, and we have to comparison with the we have to change the one parameter at one time while the other are fixed for each cathode, which means we have to change wind speed 5 ms and comparison to the one previous example. For the wind speed 5 meter per second, the original data have 1.0 meters wind speed, which is considered between 714, the lowest concentrate, to the 28,560 of highest concentrate. The dispersion present in 3 grade, that is red, green, and blue. The concentration for 5 meter per second wind speed are 142.8, the lowest, to 5,712 for the highest concentration. The change to wind speed can be changed the concentration of the pollutant dispersion. Okay, the next one is the wind direction. This is the location, and we have to change the wind direction, and then we have to change the wind speed into original one, that is 1 meter per second. For the wind direction, the data for the wind direction obtained from the example is 234, and change it to the 300 degree. The value of the concentration of pollutant dispersion to change whether 234 degree is 714 to 28,560, while for the 300 degree it is 1,390 to 67,900, which is the highest. Here it is clear that the concentration of the pollutant dispersion will change when the wind direction parameter change. That's all from me.
Assalamualaikum, my name is Muhammad Aiman bin Shukri. So I will continue our presentation for project 3 with mixing height. So the parameter will speed, wind direction, aerometer height, temperature, mixing height, and possible Gifford stability. We use from general data, but we adjust the mixing height from 200 to 700. So we can look the picture from the frame online to take concentration data. Okay, mixing height 700 meters. The mixing height parameter has been adjusted from 200 meters to 700 meters. The reading for 200 meters of mixing height between 740 to 28,516, and the reading for 700 meters is 521 to 20,840. It is a fundamental parameter that characterize the structure of the flow of the lower atmosphere and determine the volume available for dispersion of pollutants by convection of mechanical turbulence. Higher the mixing height, the higher is the volume available for the dispersion of pollutants and additives. So next is possible Gifford stability. So our group will use T neutral and parameter, another parameter like wind speed, wind direction, aerometer height, temperature, mixing height from original data. So we can look the picture from top frame online. After we adjust the possible Gifford stability to T natural. So T natural has a longer low concentration compared to medium and high concentration. We've mixed these two different at low concentration levels. This approach is based on surface wind speed, cloud cover, and the amount of solar radiation entering the atmosphere. Class E and F, they're not stable air with strong stratification that significantly reduce mechanical turbulence, typically with strong winds in steady wind direction. with moderate winds and variable condition. Class D stability is neutral. The three classes A, B, and C represent unstable situations with various level of intensive missing. Next is about conclusion for our project. So for conclusion, with this project, students can find out how to get the data about the air pollution index, API, weather forecasting in Malaysia, and air quality modeling. For project 1, with the website, every data required for the air pollution index in Malaysia is easier to obtain. The air quality index is used to report daily air quality. So with the data obtained, can classify the level of air quality in the space. For project 2, weather forecast website in Malaysia was used to record the desired data such as wind direction and wind speed in a certain place in Malaysia. Project 3 web tool for air quality modeling is used, namely TopFlam Online. TopFlam can simulate the release from a point source and can compute the plumb rise of the pollutant due to mechanical or thermal momentum. TopFlam extrapolate the wind speed at the release height according to a vertical profile that depends on land characteristic and atmospheric stability. So that's all from our group. Thank you.